2:01. Oh, we're late. Jason, we're late. I'm sorry. Folks, welcome. It's great to have you here. My name is James Stanger, and I want to talk to you today about what we're going to be talking about. More importantly, I want to talk to you today about some of the insights that I've been able to gather, not only from Bree. Everybody say hello, Bree. Hello, Bree. Bree is from Cloud Range, and Jason, so you guys wait there. They're a major part of our hands-on experience today. And we have Yuri. Everybody say hi, Yuri. He's a major part of our hands-on experience today. We have, and he's from a company called Cubic, right? So, Cloud Range Cyber, Cubic, and a little-known company, Chung, that's called AWS. Anybody heard of Amazon? No, nobody's. We're all here to be talking to you today about what it means to protect mission-critical infrastructure. Now, we are here online, and I want to introduce you to some of the people who will be facilitating this, this event that we have for the next 3 hours. I'm going to go over some housekeeping items first, and then I'm going to be going over some important background that hopefully sets things up nicely for Bree, Yuri, and Chung to talk about these things. As far as housekeeping is concerned, first of all, Ashoka in the back. Everybody say hi, Ashoka. That wasn't bad. Stephen, how you doing? Everybody say hi to Stephen there. Hi, Stephen. That was pretty good too. Usually I say that's pretty lame, but that was very good. They work for CompTIA. Stephen is going to be handling things for our online folks. Did you know that this is being recorded for posterity? It is. It's part of our CompTIA instructor network. It's also part of our effort to get this message out to as many people as possible. This means that when you stand up to ask a question, for example, Barbara, was it Barbara? I'm lousy with names, and I will never remember that name in the future. I'll probably call you Bree. So Barbara, if you want to have a question or anything, see these microphones here, folks? Please walk up to them. The reason being, maybe people in the room won't hear you, but definitely the people online won't hear you. So let me talk about a few more housekeeping things here before we continue. One of these days I'll get the, all right, good. Housekeeping, first of all, you're going to be seeing a QR code here in just a few minutes. You guys trust QR codes? No? Yep, I'm going to rickroll you. You know what rickrolling is? Right? Where you get to, yeah, don't worry, I'm not going to rickroll you. I guess you'll have to trust me. You're going to see a QR code here in a few minutes, a couple of them. One of them is going to allow you to log in online so you can follow any questions that online people have. You know what I'm trying to say? We want to unify people as much as possible. You're also going to see another QR code that is going to allow you to download the slides that Yuri and Bree have created. I hope that's all right. I don't think I asked you to. I hope that's copacetic. The other thing that I want to bring up is this. We're going to have a raffle at the end. Who here has one of these cute little raffle cards? Who doesn't? Well, you don't get to raffle. No, just kidding. Let me hand these out real quick. Thank you very much, Jason. Please fill out your name and get these either to Ashoka or to Stephen, okay? What's a raffle for? A voucher of your choice for a CompTIA cert. Fair enough? Now, you got to be here at the end to get it, okay? Now, there's another housekeeping thing. Who here is doing things, showing up here for some sort of CE credit? If you are, at the end of the presentation, and by the end of the presentation, I mean 3 hours from now, there's going to be a machine back here that you can tap out on. 1, don't forget to do that. 2, don't do it now. You do it at the end. It won't accept you at the beginning. Does that make any sense, folks, about tapping out here? Have you ever noticed Jason is hogging the spotlight? You ever noticed that? So good. So thanks, Jason. I appreciate this. Additional housekeeping. For those of you who are online, hello, everyone online. Greetings from Honolulu. We are going to be doing some cool demos as soon as I stop talking here. And the demos, folks online, you're going to be seated on this screen here. Now, folks in person, you're going to see it right here. Online, a screen will show up. Stephen, what's the name of that screen called? It's called the what? Media player. The media player, that's what it's called. That screen, folks, online, and I'm looking right at you, is really small. Don't ask Stephen to resize it. I can't resize it for you, but you can resize it and make it so that you can see what Yuri and Bree are doing. Fair enough? So I think we're about at the end of the housekeeping. Oh, I'm James, yes, Ashoka? Why don't you come up to the microphone and you can, so everybody can hear you.
What do we need on the card? Can we ask for name and email address?
Oh, I'm sorry, yeah, I guess it'd be better than name. Your name and email address. Guys, what are you gonna put on here?
Thank you.
That was really lame. 1, 2, 3. Name and, thank you. Because we need to be able to contact you. But again, you need to be here for that. Fair enough? Now, there's something that I always do. I call it the Stanger selfie. And trust me, we're going to get to the presentation here in a second. So what I need y'all, did I do that very well, Stephen? Y'all, it was okay. What I need y'all to do is stand up. And please stand up, and I'm going to do what I call the Stanger selfie. If you don't want to be online, if you're afraid of somebody noticing that you are here rather than supposed to be at work, but if everybody could gather together here and just step very close. There you go. Get right. This is Chung here from AWS. Get as close to him as possible, okay?
Very long arms.
There you go. So everybody come here. We'd love to have you two join in as well. Jason, where are you? For those of you who don't want to join in, that's perfectly fine. That's great. Come on over here. Jason, we should have you up here if you want. It's selfie time, so please get close together. I'm going to do it right here. That's looking pretty good. All right. Can you scoot up a little bit more? Because my huge head and my even bigger hair tends to get in the way. Okay, after 3, CompTIA, shall we? CompTIA on 3. 1, 2, 3. CompTIA. Thank you very much, folks. Now, please sit down and stop wasting my time. We're going to get on with the presentation. I mean, for heaven's sake, people, really. Okay, Jason earlier, and I think was it Jason? Who was it? Was it also Yuri? I think you were guessing what that bridge is. You may know what that bridge is? It's a bridge. Where's the bridge? Yeah, that's Sydney, Australia. Put that up here because of mission-critical infrastructure. You probably can't tell, but if you were to look close at that picture, you'll see people walking up it. You can actually walk up there. Didn't have a chance to do an outside walk up the bridge. Maybe next time, not enough time. I thought I would bring this up because there's a lot of mission-critical infrastructure that you're looking at. Buildings, ships, suggestive of maritime. We're doing a lot of that kind of work. At CompTIA, folks, we solve problems. Over the decades, we solved problems. Back in the 90s, we solved a help desk problem. Companies around the world had terrible help desks, and they needed help. That's why we created A+. Throughout the decades, we've been solving problems. Today, we're focusing on hands-on learning having to do with not only tech support, but cybersecurity, development, infrastructure, also artificial intelligence. We have pathways. Who here is Security Plus certified? So you're on our Security Plus pathway, you're on our Security pathway. Who's A+? Anybody studying for Linux Plus? There we go, very good. Folks, what is going to solve today's problems? And CompTIA, we have identified, just like most people really have, that hands-on practical learning is going to do it. And this is probably where I'm going to pull you in just for a second, Chung, about the importance of things like cyber ranges and hands-on learning. The thing I want to point out here in this introductory discussion is, well, why is CompTIA doing a hands-on workshop? Now, we've done a lot of workshops. I've done them over the years. In fact, I was just in Australia, did a day-long workshop in AI and cybersecurity. That was fun. But we're very interested with Cloud Range Cyber. We're very interested with what Yuri's doing, with what AWS, their perception is about the importance of cyber ranges. From an AWS perspective, this is where I get to put you on the spot, Chung. And do you have a microphone so we can hear you? Why don't you go stand up here on this here. What is it about cyber ranges, what is it about hands-on practical exercises that makes it so important to learn these concepts and these practices?
So hi folks again, Chung with AWS, right? So I think like many of maybe possibly the older generations in this room, right? We know the importance of hands-on training and hands-on experience, right? And our first time hands-on experience was when the attack actually happened, right? We don't want that to happen to you guys, right? Because that's how it normally works, right? You get thrown in the fire and then you figure it out. Because, well, like many companies, many organizations I could go talk to don't have a really good test bed, right? They have dev, they have kind of like, closed QA, but then they don't really have a test bed where you can just go to town on the infrastructure, right? Because it's expensive, it's time consuming, but nowhere else can you get a hands-on experience like in the cyber range, where you're replicating live, real-world scenarios. That's why it's so important.
Mm-hmm. Thank you very much. Yuri, Bree, I'm going to put you on the spot. You and I were talking about how you go to Cyber Range every year and you end up with a list of things that you weren't sure you knew or the additional things, right?
Yeah. Do I have a microphone? Do I have to turn it on? Or?
I think she'll turn it on for you.
Got me? Okay. Yeah, so I am on a staff that runs the largest unclassified exercise for the DoD called Cyber Shield. It's about 2,000. No. Am I good? All right. And so we do it every year. It gives me the learning list of the topics that I need to learn every single year, that laundry list of items. If you work in this field, regardless of your role, managerial, operational, technical, you understand the need to consistently learn, consistently adapt, consistently build a new skill set, because attackers are consistently learning and changing their techniques, and exploits are consistently changing, and technology is consistently changing, so we have to adapt as well.
Both Bree and Yuri have really cool online things that we're going to be showing you, but I just want to emphasize the idea of cyber ranges. What it does is it does kind of what I would call an unwitting tabletop exercise. Has anybody here ever heard of a tabletop exercise before? Raise your hands. Basically where you go over what the incident response plan is, for example. Right? I get it. Now, cyber ranges will never really say they're a tabletop exercise. Sometimes you can have a tabletop exercise in a cyber range. It's not quite what I'm talking about. What I'm talking about is cyber ranges have an uncanny and positive way of getting organizations to not just workers, to not just focus on the technical side of things, which I love. I love the tech side. But they also tend to allow people to focus on how the tech supports the business. Whether that business be a government, or an enterprise, or a healthcare company, or what have you. You guys know what I'm trying to say? It helps people identify what they didn't know before. Kind of the unknown factor. So I'm James Stanger. I've been a company president before. I'm a working technologist. I've done pen tests over the years. Lately I've been doing a lot of things having to do with AI and cybersecurity policy, and also with the idea of incident response. Now we've got Yuri and Bree, and we've got, not Chris, sorry, but we have Chung with us today, and Jason, and they are our guests and are going to be talking to us specifically about some of the things we need to learn. So first thing, here's the QR code that you can grab yourselves and follow with the online conversation. Fair enough? So grab that QR code, grab your QR code reader, and it allows you to begin the login so that everybody online and in person are one. How about that? Because we want this to be as hands-on and as cooperative as possible. As you have questions, folks, one reason why I have people stand up and do that silly little selfie is I want you to be unafraid to ask questions of Bree and of Yuri, of myself and of Chung. The more interactive this is, the better. Second, I already talked about the raffle. Please, if you don't have it, again, we've got these cards. Fill out your name. Fill out your email. At the end of this session, we will have a drawing there. If you want the slides that you're going to be seeing, here they are. Grab that QR code, and you can download all the slides. They ain't small. That picture of the Sydney Bridge was like 8 megabytes already, so sorry about that. So there's the QR code there. Let me do a little preamble, and then we'll get on with Bree next, and then with Yuri, who have brought some fantastic stuff. So for example, Yuri has brought this stuff physically in. When I say this stuff, it's a cyber environment that you're going to be taking a good look into. Bree has a cyber range that she's going to have online for you. But here's the situation. And the situation, I think, is rather interesting. I used to talk about the tech trifecta. I like fancy terms. Cloud, data center, and on-prem. Is on-prem still a thing? Has it gone away? Never will. So there's the tech trifecta, right? Data centers will never go away. In fact, when I was in Australia and Europe real recently, they have specific data center initiatives. to complement the cloud and also to be an alternative to big tech cloud. But as Yoda would say, there is another. And what is the other? Operational technology. So the critical quad. The idea is, how do we teach what it means to be cloud smart? What does cloud smart mean? Well, it means using all three of these things. Four of these things. You're going to be hearing today, folks, about or seeing hacker life cycles, as it were. What an attack looks like from an APT group. Anybody heard what an APT group, Advanced Persistent Threat Group, is? You're going to be hearing terms such as lateral movement, etc. And anybody know the Lockheed Martin cyber kill chain? Okay, that's one model. There's another, the MITRE ATT&CK model. There's the diamond model, which is used a lot in AI to map the adversary's capability versus the victim's infrastructure is one way to look at it. But the whole idea is to take a look at the tactics, techniques, and procedures, the TTPs, and to see them hands-on. And I want to talk about perspectives real quick. Anybody want to guess who this is? Yes, it's my fourth granddaughter. She just got born. She just showed up here, I want to say, in June. There she is, both in utero and not. What does that have to do with anything, James? Well, it actually does. Because when it comes to visualizing your learning pathway or visualizing attacks, here we are visualizing a human being. That is a visualizing technology. Simple, what is that? What's the term for that? Sonogram? Recently, at another event, we had a power loss here at my house. And I just wanted to point out there's different ways to visualize that. Well, what do I mean? Well, here's the outage map. There's where I live, and you can see where that was a real mess for about a day before they cleaned it up. You could visualize that by how much my UPS, how low it got. You can visualize that by looking at the hardware. My point in showing this picture of my granddaughter, but also showing this outage map and what it means for when I was using my Jackery to power up the stuff in my house, there are a lot of different ways in which you can understand and visualize an event. Whether that event be a DNS outage, like we saw at AWS this past week, was it this last week? Whether it be a hack that you're going to see Bree and Yuri talk about. But I want to bring up the infrastructure, the considerations here that have to do with infrastructure and perimeter. You're going to hear terms like identity management, for example. You're going to hear terms like the edge. These are the elements that are all going to be operative for you to understand. I wanted to give a background so that when Yuri and Bree bring up some of these terms, that they're not the first time you've heard them. From a learning perspective, from an instructor's perspective, I want you to see those terms and understand them so that when Bree brings it up, you'll feel comfortable and go, hey, I'm not quite sure what you mean by at the edge. Or you just talked about lateral movement, and now you're talking about persistence, and now you're going to talk about data egress or whatever. So feel free to ask questions specifically about that. Fair enough, folks? Now, how do we teach these compelling things? Well, that lady right there is a lord in the Houses of Parliament in the UK. And I was in Lancaster, UK recently, where we were in a university where they had put together an AI-enabled cyber range. It was pretty interesting. And the reason why I'm emphasizing the importance of hands-on is because we can talk all day long about where a web server and a SQL server work together and an attacker does a SQL injection, or where a human being falls prey to a business email compromise, or what have you. I call these interstices. Whenever one technology interfaces with another, there's that middle space there. It's kind of like your teeth, that's why we floss, to get into the hard-to-reach places. That's where the hackers live. Bree and Yuri are going to show you where those hackers are living, and you're going to be able to visualize those things. So I just want to just use an example. Recently, I was in Australia. You've probably never heard of a thing called a cassowary before. You ever heard of a cassowary? Anybody raise? Yuri, you have. You're about 6 feet tall, aren't you? Stand up, folks. A cassowary is as tall as that guy. It's kind of like an emu or an ostrich, okay? And that sign there is basically saying, beware of the cassowaries. You tend not to see them. What do you guys see here? That's a rainforest, okay? It's a rainforest in Australia. Can you see something a little blue there? Can you see something a little blue right here? That's a cassowary hiding. Trust me, they're very difficult to spot. I talked to a person who, sorry about that. I talked to a person who is a crocodile person. He was showing me where some crocs were in Australia. And I said, are you going to be able to see things like cassowaries? And he's like, good luck, no one ever sees them. Well, sure enough, we were able to find one. What Bree and Yuri are going to be doing is not showing you cassowaries, but showing you something rare. And in fact, we were lucky enough to where we didn't scare it out. In fact, it kind of scared us. It actually came out and started walking out in the middle of the road. There it is. I took that picture. I bring this up, folks, because these two and Chung, these three, are going to be talking to you and showing you how to bring out these things. Because our industry is looking for cybersecurity #1. And our latest report, even though AI is a big topic, notice that cybersecurity is listed higher. And specifically, areas of cybersecurity, I don't know if you can see these here, these elements here, but we're talking about using AI to improve internal operations. Good luck with that. I do think orchestration and automation will help. But I do want to point out that when it comes to using AI, the idea is to use automation to help enable defenders, and specifically monitoring of network traffic, generating defense tests, kind of like predictive analytics, to predict future breaches, to automate incident response. That's one thing, Yuri, you and I were talking about the importance of self-healing networks and things like that. Whether it be AI doing these things or not, and again, I'm just re-emphasizing these areas, monitoring of network traffic, generating defense tests, whether you're using AI, it doesn't matter. What Yuri and Chung and what Bree are going to be talking about are elements here that are top areas, specifically network infrastructure security, understanding the threat landscape. You know, there have been various perspectives that we've seen over time, folks. Somebody just knocked over the poster back there. Don't worry about it. The idea of securing the perimeter, or defense in depth, or identity is the new perimeter, securing data. These are all perspectives, folks, that are all valid. Okay? Some people will say, well, one's old-fashioned and another one's not good, or others are good. I would say that these are all different lenses that you can apply. And these are phrases and things that I've heard over the last year in my global travels. It's been a lot of fun. Observability is really interesting to me. It's the idea that you take log files, you take traces, and the normal performance metrics and find ways to manage your cybersecurity in terms of customer service. But the idea of the skills that are needed to secure mission-critical infrastructure. And these skills, I've learned these things. There's a group of people from South America who work for companies around the world. In fact, there's a couple of AWS people in there. These are folks from Australia. These are some of the skills that seem to be #1, okay? That seem to be at the top of mind to support complex system interactions and things like that. Identity and credential access management. These are all very important things to be thinking about. So thank you. I want to turn the time now over to Bree at Cloud Range. If anybody has any comments or questions, once again, please come up to the microphone here. I'm going to sit down, and everybody, if you could give Bree a great big hand.
Let's see if, no. That's not nice.
I'm going to take away that computer so I can get it out of your head.
Okay.
Thank you.
I'm going to have Jason join me.
There you go. You have to plug yourself in.
All right, thank you.
Welcome to Jason's up there. Does anybody have any particular questions at all, either about housekeeping or anything else? Stephen, any questions online? Bree, if anything comes up, feel free to walk up and you can answer questions. Feel free to walk up to the microphone here and we'll get to you.
All right. Awesome. So I am our Director of Product from Cloud Range. This is Jason. He is our CRO. And we are here to talk to you about cyber ranges. How many of you have a technology, doesn't have to be cyber, certification of some sort? Okay. How many of you have a CompTIA certification? And how many of you have an AWS certification? Awesome. Sweet. Okay, how many of you have actually run through a full incident from investigation all the way through mitigation and remediation? Hands on keyboard. Okay, all right. So those are my people in the crowd. I'm going to be asking questions to get engagement. As I kind of run through this simulation and scenario, you do not have to walk up to the mic to answer my questions. I will repeat your answers. And I am totally not above bribing you with candy to engage with me, okay? I also promise that technical background or not technical background, everyone can participate. Everyone can answer any questions that we've got. It's more about the mindset and the methodology of how attacks work. And you will also get candy. And hopefully we'll all walk away from here having a little bit of fun, learning something. And if not, well, I'm giving you candy, so you have to like me, right? And they're the best candies, arguably. Sour Patch watermelons are the best candies, unless you give me Reese's pumpkins, and then we can fight about it. But, all right. Okay, Jason, tell us about Cloud Range.
So I stand between you and the actual range experience, so I'll be really fast. First of all, I can attest that everybody can participate no matter what their level of skill is, because Bree walked me through this yesterday, and I was able to trust her to do it. So Cloud Range, this is what we do. Like a flight simulator is for a pilot, we are for the cybersecurity community. Who here would want to go on a plane knowing that the pilot has only done what? Hello, hello? Okay. Grab. Still stash. Everybody hear me now? Oh yeah, okay, here we go. All right, I know everybody in the room can hear me. Nobody has ever accused me of being quiet. So a little bit about Cloud Range very quickly. We provide a cyber range experience. It is a range as a service. So all you literally need to do is have a username and password. You don't even need that today because Bree's going to be doing that activity for you. But our customers come in and literally just username and password, log in, and they're able to experience the given mission that day. And you're going to experience one today. So we have everything from AI, of course, that's the buzzword. We can't get 6 minutes without dropping the word AI. So we have AI attacks, cloud attacks, everything that's out in the wild today. We have everything from novice all the way up to very, very advanced, and we add 2 to 4 new ones every month because, of course, there are new ones every month. We also bridge that process from the technical troubleshooting processes through to that tabletop exercise so that people have to learn how to effectively communicate onto the executives, and then the executives have to decide what to do with regulatory bodies, with Wall Street, with whatever they might have to do. We also do red teaming, blue teaming, purple teams, etc. And we have augmented labs. So if I think James' example was about SQL injections, so if I am bad at SQL injections, it comes out during the mission itself, then we can note that, and there's supplemental training for me to take around SQL injections. So that's a little bit about us. Our mission is to help organizations, institutions around the world be battle tested and ready. It's not if we get attacked, it's when we get attacked. And so our goal is that as soon as that attack occurs, the team doesn't have to think about what to do, they just know what to do. And I can tell you, like, we're very fortunate. We've been working with our customers for a number of years, and while we don't want them to get attacked, it is very, it feels very rewarding when the CIO calls us afterward and says, our team operates so quickly because they were trained. There's trained and untrained, our team was ready. And of course, it's not to take away, matter of fact, it complements the certifications that CompTIA and others do. So a little bit what makes us unique, like we said, there's no hardware like that. You heard Bree mention about OT, so we have OT scenarios, IT scenarios, all different sorts there. The traditional tools that you're going to use in a normal attack situation, the SIMs, the firewalls, they're all already part of the actual range itself. So think of the Gartner Magic Quadrant. We got those already in there for you. So you're gaining the knowledge of the tools that you're actually going to use during the mission itself. And just like going to the gym, these are we think of it as a program, and we're focused on the team. It's how the team executes against the incident response plan. And we, no, that's okay. I thought it was a subtle wave telling me I'm over time. No, and so we, yeah. So just like if you were to go to the gym one time, you don't get in shape. You just learn that you need to go to the gym. So for us, we tend to do them once per month with our customers, and that way they literally can go from novice to intermediate to advanced to super advanced, et cetera. We also have traffic, because that's what happens in real life attacks. While you are investigating and doing all those types of things, your network is still in motion, our range is still in motion. And so that's a little bit about us. I'm very happy to answer any questions, of course, now or afterwards. If you have any interest in talking, I'll be here the whole time. Yep, that's it.
All right, so we are going to run into a scenario that is done by an APT called Energetic Panda. They are from China. Jason, can you do me a favor? Over here. Can you pull up the slide deck that I have here? Okay, so who is Energetic Panda? Energetic Panda, also known as they are, is this aquatic? No, Wicked Panda and Double Dragon. They are from China, and they have over 46 malware families that they have utilized and typically use spear phishing as a method of initial access. They have been known for multiple attacks and multiple breaches across all of the critical industry sectors, specifically notorious for hitting the Kuwaiti government, as well as transportation and shipping industries within Kuwait. So the attack that we are going to be running through today is reminiscent of an APT attack and their techniques for Energetic Panda. Okay, ready to play? All right, let's go. This is our prompt. We start every scenario with a prompt, so we know where to start. So our prompt today is another organization CIO contacted Holy organization. We are Holy with an E, Holy. There might be a few misconfigurations within our network. And reported that while they were investigating an attack, they discovered the Holy's Active Directory records and files on their system. All right, so keep that in mind. That's where we're starting. And we are now jumping into our range. Can you guys see that okay? Nope. Let's see. It was nice and big earlier. Oh, now it's giant. All right, that was exciting. We'll do, oh, that's just all it allows me to do. That's exciting. Okay, all right, so we are going to jump in and pull up our network diagrams. That's where we'll start. Yeah, I know, those are way too tiny. Actually, I'm gonna grab a mouse. Perfect, thank you. Your mouse work? All right, no, we're not. Okay, so here is our network that we are jumping into. Can you see that okay-ish? All right. Okay, cool. So over here, we have a DMZ segment. This has all of our websites, our web servers, a kiosk. This is one subnet section of our network. Okay, we have a DMZ firewall over here. We have a subnet for our servers. So we have the domain controller, the DNS server exchange, and 2 file servers. We have our user segment for our user endpoints, our user workstations. We have a SOC segment. So these are all of our SOC workstations. If you were to run a mission with Cloud Range, everyone participating in the mission all gets their own SOC workstation, which is why there's so many SOC stations. We have database segment right here. network segmentation for our customers to access customer network, and then we have our SIEM. Over here, if we go over to the next tab, we also have an OT firewall that you see, and that separates our OT environment. All right, perfect. So you can see we have Clarity and Nozomi. We have an OT domain controller. We have an engineering workstation, a couple engineering workstations, Linux, file server, chemical plant, PLCs, and HMIs, and the SCADA bridge. Okay, so we have landed in this network. We are an incident responder on a SOC workstation. The prompt said, our Active Directory records have been leaked. What is Active Directory, and why is it bad if they get leaked? Anyone? Candy, what? Access to what is everything? What is everything? User accounts, good passwords, credentials, user stations, everything. Okay? Second question. Where does Active Directory usually sit? Where does it get stored? There you go, domain controller. Yep, perfect. Okay. So, sorry, my notes are here. And okay, now what kind of user can access Active Directory? Privileged user. Perfect, that's what I was looking for. Hopefully online can hear me. I'm trying to repeat the answers as they give them. Privileged user. Okay, now, so if we were to look in a particular tool that would maybe see successful logons from privileged users, anyone know where that would be? What tool that is? Authorization logs? Perfect. SIEM is what we're looking for. So for this range particularly, I spun up Splunk. That's what I'm most comfortable with. We have a whole bunch of others. But let's go ahead and log into Splunk. Oh, it's right here. Okay, great. Now, does anyone know the event ID of a successful logon? Top of your head. Here's the best part about security. I love telling this story. A young kid of mine, mentee, just got into cyber, and when we were talking about his goal, he was like, I hear you talk, and I just don't think I'm smart enough to be into cyber. Like, I just don't get it. Like, I've never done well in school. I just don't think I'm smart enough. 17-year-old kid, amazing kid. And I was like, it's not about how smart you are. It's about if you know how to find the right answers in particular places and where to look. So guess what? We have Google. So we're looking for successful logon Windows ID, or event ID. Oops. 4624. Okay? So we're going to go to our range. Okay. All right. So we are going to go to host equals 92.168.200.1, which I happen to know is the IP address of the domain controller. I can do that. There we go. Is that better? Oh, it keeps going down, though. Yeah, I have a Mac. What? No. Okay. It is nice and, oh, reduce. I see. Okay, thank you. $46.24. the Wi-Fi is having a minute. Okay, perfect. So we have successful logon here. We can look at a couple of these now. Does anybody know how general authentication works with a domain controller? What type of authentication it requests? Gives tickets? There we go, Kerberos. Candy for you. Fantastic. Okay, great. So Kerberos is how this actually works. We can look at that. We can take it out, how we're trying to filter through that data. We can look at different particular IP addresses that hit this domain controller. Knowing that our Active Directories were leaked out, we are pretty suspicious that there was at least some kind of attacker activity on that domain controller. So when we look through these IP addresses, oftentimes in security, we're not looking for the IP with the largest amount of traffic. We're looking for those strange anomalies, right? We're looking for the needle in the haystack. We're not looking for the IP that did 300 requests. We're looking for the IP that did 3. So as we're kind of looking through these, like there's some servers here, knowing that like the file server right here, this is our, I think this is our print server. We can go look at rare values and see what we see here. Okay. And this scrolling is not great. And this is not working either. There we go. Okay, anything that you see that's 172 is our range network, so we can filter out anything 172 traffic. It does not like that at all. Okay, we have right here, this 192.168.100. These are our user workstations. They are accessing our domain controller. So as a typical incident response team, we can kind of start to look into this and go through each one. But we have, we want to look into workstation 1 and 3 as kind of fast forwarding through this. So we'll look through .120 as we start to kind of dig into these, and I'll show you where I get that from. So these are all different workstation 1 and workstation 2. So if we look at the events, we see 120 here, and we start to kind of go through some of this traffic and filter through. So we see all the Kerberos traffic, and the other thing that we can look at is usernames to get through. Where is my... Okay, so typically when you hit a workstation, you have a user that logs into a workstation and it has that workstation requests a Kerberos ticket, domain controller grants it, and then the two stations are connected and able to get that access. Now, right here, we have a couple logins where a user with a username and the username credentials logged directly into the domain controller. So looking at this traffic, we can start to see that this is a log on type 3. Does anyone know what log on type 3 is, incident responders? So that means that the user, instead of logging into Jason, logged into Jason's workstation, and Jason's workstation made a request to the domain controller, it means that the user, Jason, jumped on and remotely logged on to the domain controller using his direct credentials. That's what log on type 3 means. And that is a cause for concern. So now that we're looking at, and so now we're looking at the, this does not scroll. I don't know if it's the internet or something, but it's definitely having a... Okay, so we see Rick, Virginia, and we see his IP address. So by looking at the network map, what appliance sits between the user workstations and the domain controller. The firewall, right. So let's go ahead and go to the firewall logs and start looking at some of those network connections. Spun up Palo Alto firewall for this range. So we're going to put here in, I'm going to explain what I'm doing in case it's too small for you to see. The IP address, the source IP address here, and the destination is the domain controller. Okay, so we're looking at traffic in between the two, and you're going to see a lot of DNS traffic here. And that makes sense because if we were to dig, we would see that the environment is intentionally set up and this firewall is misconfigured to run as a DNS server rather than a dedicated DNS server within the environment. So we can just take out and put a NOT here and filter out that DNS traffic. Okay, great. Does anybody see anything interesting about these particular connections? Anything that looks suspicious? What about this right here? What is this? I know, it's right here. What's this? What's 445? Anyone? SMB, nice, there you go. Okay. No. What does SMB stand for? Anyone know? Server message block. Where does SMB come from? It's in the title, hint. The server, right? So this is coming from a user workstation. Usually SMB is used for file servers, print servers, share things. It's kind of like FTP, shares things back and forth between those two particular types of servers. So this is between a domain controller and a user workstation using SMB. That's pretty atypical. That's not normal. Okay, perfect. There's also 3 different independent SMB connections, which is a concern. And then what else do we have? What's this? This is a port, the port column. What is this? Does anyone know what this is called? A high ephemeral port. Perfect. Yep. Does anyone know what they usually use high ephemeral ports for? Outbound connections. Perfect. Awesome. Okay, so that's exactly another cause for concern. So one last thing here that looks funky to me is this right here. So working in security, you see a lot of PowerShell traffic, specifically a tool used by PowerShell called psexec. The executable, so the program that executes of psexec uses port 135. And then uses a protocol called RPC. Does anyone know what RPC stands for? I hope you're looking it up on Google. That's awesome. Yes?
I know it's remote communication.
Exactly, right. So kind of, it's remote procedural call. So there is a tool running a remote command using this protocol on our domain controller from a user workstation, using high ephemeral port connections that should typically be used for outbound, and SMB traffic. All 3 of those are super big red flag. Does anyone know what this looks like? If you look at this, let's see if I have to like move it. Nope, move it down. Okay, so you can't see this super well, but if you were to look, it also comes at a pretty normal cadence. So like SMB is 7.3, SMB is 7.3, SMB is 7.3. The same protocols that are repeating are also pulling out the same amount of bytes and the same consistent cadence. Does anyone know or can you guess about what that looks like? Huh? No. There you go. C2, command and control, right? And so someone is connecting to this box, giving it a directive, and it is connecting back out, most likely to the attacker's IP address. And that is how they, threat actors use to send remote commands to a computer. Let's see, let's go through my notes. Oh, okay, also, this was the first thing I thought about. If we had records exfiltrated from our domain controller, what connection would that look like? So the domain controller kind of manages all of your computers within your network, all internal connections within. What type of connection should we never have from a domain controller? An external connection? Nothing externally from our network ever needs to touch our domain controller. That's solely dedicated to managing everything inside of our network. Should never have an external connection hitting that. So let's go look at that real quick. Not add or dead. Okay, we can also take out, I think we have like Google and AT&T in here, so we'll filter those out. Okay, these IPs that we're seeing, over what port? So this particular 9.8.7.66, over what port? 8080, which is typically what? HTTP. Can you make this so this doesn't time out for me, please? That would be great. Okay, so this tells me, so when we start looking at this, so again, when we look at the bytes, it's consistent bytes, 374, 374, 374, 374. There's some DNS traffic and stuff in here that we could go in. Again, it's configured to be a DNS server incorrectly. We can usually just filter out the DNS traffic here because we know that's a misconfiguration. But looking at this 374, my guess is that this is the attacker's IP address because this is what's connecting directly to our domain server, remember, and consistently exfiltrating out that same number of data, that same number of bytes. So that is an IP address that we want to write down as an IOC and make sure that we mark that and look into it. So we can look here, and let's look at that specific IP address to see. Oh, man. .8.7.66, right? Okay, so this is what's hitting this particular external IP address. So we have the 200.1, that's our domain controller. We have the 100.120, that's Rick Virginia's workstation that we've already identified as a potentially compromised endpoint. And then we have 200.6, which is our file server. These are all right here on our network map. I just have them memorized. So we'll also write down that the file server is an additional endpoint that we want to go dive into. Okay, so we have those three potentially compromised boxes. Where do we go from here? Anyone want to guess? Anyone want to take a swing? Anyone want to go look at the user's workstation to see maybe we can identify what the point of initial access was? Yeah? Go look at Rick Virginia's workstation. So we have these, right? We kind of looked at the domain controller, and we'll look a little bit more at the traffic there a little bit later. We have the user workstation, and we have the file server. So let's go ahead and just start looking at his workstation. And it is... Nope. I need that. I'm an incident responder. Well, right, we're playing incident responder. So yeah, so we're logging in as Rick Virginia to see if we can replicate what the initial access was. Man, I always type this password wrong.
They come up with numbers like 120 days or 120 hours. You guys know what I'm trying to say? Notice the time it takes to do the find.
Oh, I know what I did wrong. Can you go back? I know. I didn't put the domain.
My point being that it makes it sound like a long time for a hacker to do for X number of hours or what have you. It takes time to go. Sorry, go ahead.
No, you're great. Thank you. Okay, so logging into the user's workstation, we immediately see a problem. What's this? PowerShell. So we see an email. Anyone see a problem with the email on first login, first attempt login? What? Yeah, macro enabled is so this attachment right here says pipeline.docum. .docum extension is a macro enabled document meant to have good automation capabilities. Ended up turning into something pretty malicious that we don't generally support anymore. So, yeah. Right. Oh, yeah. So we see the download. So this is a lovely safe range environment, so we're just going to go ahead and open the file and see what's happening here. If you play incident responder on your networks, please don't do that. If you walk away from anything learning that, learn that. Unless you want to talk to your security team real quick. Correct. Correct. Oh, come on. All right, so we're going to look and see what this thing is doing in a safe environment. All right, let me make this a little bigger. Okay. All right. What do you see here? What is this doing? Anyone want to take a guess? I heard it. Get requests to what? So this is a different IP, but yeah, to an external IP address. INOT-info, an executable. Why is it a problem that it is called INET-info? Yes, so INET-info is a legitimate Windows process, and it is a technique that attackers often use to name their malicious programs or the malicious malware so that it obfuscates it in normal traffic, because you'll see the process INET-info and a lot of security teams, it won't cause an alert or cause a false positive. A lot of people just don't see it and don't identify it. However, they messed up here. Where is Windows processes, what folder is Windows processes usually launched from? System 32. Where are they saving it here? Windows temp. So as we're trying to filter through what traffic is malicious and what traffic is actually legitimate Windows, we can just create this and add it to the path variable as we're kind of walking through this. So anything Windows temp, where that kind of gives us our first hint on that is a malicious identifier. Okay. Okay, so we got a couple new IOCs here. So if you are playing Incident Reporter, you make sure to write down inetinfo.exe, Windows temp, inetinfo.exe, because we're using the entire path variable, and the new IP address that we have nailed down. So let's go back to Splunk, and we are going to go identify using these new IOCs that we've just discovered. And I'm going to do this nice and easy, and I'm going to type in inetinfo.exe, and we'll see what we get. All right. So what do we see here? Sorry, I'm going to try to go real slow because this is extra jumpy on this internet connection. What is, so right here, I'll highlight these so you can see them. What is a process we would see called, where'd it go? Apache, it's ab.exe or Apache Bench Command Line Utility. Anyone know what that is? Good, I didn't want you to. Because we're going to Google it again. It's here somewhere, inetinfo, parent process. Oh, right here, original file name, ab.exe. What is the first thing we find? Right here. Okay, fourth down. Commonly used by what? Metasploit payloads. Metasploit is a commonly used attacker tool. So this Apache benchmark binary is used to drop and transition payloads. Awesome. So we're seeing them use that, and then we're kind of looking into the traffic to see what they're doing. So command.exe, they're looking in the C directory, and they're looking at the shares, drives, documents, network diagrams. That's not great. They're using kind of C, shares, inetinfo. Going a little bit further, we see command.executable, C drive directory, shares, documents, a folder called secrets. That's probably bad. C shares documents. So we're kind of looking and watching through their actions and going backwards through their steps. The way Splunk works is the last action that happened is on the top, so we're kind of going backwards through their actions and running through their attack process here. So we see their shares drive kind of all the steps they're taking. Sysmon, INA info. Uh-oh. What's that? Does anyone know what that is? Yeah, they're creating a registry key. Does anyone know why someone would do that? I heard it. Yeah, oh, you get candy. Jason is slacking. Oh, and his arm is better than mine, so sorry. They are creating persistence. So now you can see, does anyone know what this registry key would do? I know it's tiny, I'm sorry. Exactly. Anytime anything runs, attacker now has another form of access and is another way to get into the network using this INA info executable. So another callback. That's bad. Windows system con host force v, yep. Creating processes. Now they're running that registry key. Oh, this was fun. Where'd they go? NetView. What command does NetView give you? All your network information? Network shares? Yep, that's exactly what they're doing. So you go, okay, cool, they did NetView. Also, when I say cool, I mean not cool. Just make sure we're clear. ipconfig all, looking at their network configuration. System info, yep, there's exactly what I said. You nailed it. They're doing enumeration on the network. Who am I? Yep. All right, and here we see some creds. That's fun. Windows temp, P64. That's the PowerShell using the psexec. And then they're using the username, password to HN files and creating a shares drive that drops that inainfo.exe. Same, right? Logging in. Rick.Virginia. Dang it. Okay, there was one more I wanted to show. Oh, right here. Can I go down? Will let me scroll? Okay, so right here you can see command executable C copy a Z drive. So Z drive is something we haven't seen. It's also something we know doesn't exist. So what is happening, I don't know why this won't scroll anymore. It definitely got stuck. Okay, maybe it's the bottom of the window. So they're creating Z drive, X drive, and if you go deeper into this, they're creating a bunch of shared drives on the file server and on the user workstation, and that's how they're using it to spread INA info around the network. Okay, let's see if I got everything. That was a lot. Okay, there's one more location we have not looked at yet. What's that? We looked at main controller. We looked at the user workstation. What's left? There was 3. We identified 3 potentially compromised file server. Great, awesome. Handy. Oh, that was so loud. I'm either overshooting or undershooting, you guys. Sorry, sports is not my thing. Awesome. Okay, so let's go ahead and log into the file server. This one was. All right. We are here on the file server. So let's go ahead and look at our network. I don't see like any shares mounted. But if we go and we look in the C drive, shares, boop, what's up? If you can't see it, right here it says iNet info, and it's an executable. That's our RAT, a remote access Trojan that the attackers are using. Okay, so we know that they have access to our file server. Let's go ahead and look at what they found. We know they went to net diagrams, ICS net. Well, that doesn't look too bad. But does anyone else remember the other folder that they got? Secrets. Oh no. CIA and FBI. Which ones do you guys want to look at first? Actually, both are very fun. This is my favorite part. You want to go FBI first? All right. Give me ideas. What do you want to see? Counter intel. All right. Whoops. Some of these are great. Let's see if it will pull up. Rockefeller Commission. Yeah, this probably shouldn't be leaked out. Fidel Castro, cross references. Investigations. Oh, who killed Biggie Smalls? Awesome. Yeah, there was a bunch of really fun ones in here. Hemingway, Steve Jobs was interesting. Malcolm X, Eazy-E. Yeah. All right. So looking at the CIA. I mean, I know which one I was most interested in, but you tell me yours. There you go. Yeah. Where's my UFO people? Right there.
I didn't hear it. What was it?
UFOs. Oh, come on. Tell me there's some good pictures. Nah. But secret, classified information. I mean, I can go down this rabbit hole all day, so I will not. Super fun. Not fun. Bad. Classified information leaking out of a network. This is something you have to incorporate in your report to your executives or your commander or wherever you work. This is high bad, big bad, right? I think we can all agree with that.
Isn't what you just showed here very similar to what the help me out here with the shadow hackers back in the day when they grabbed all their information, and all ends up in data systems when they grabbed it and execute it from the next day.
Yeah, that's bad.
Followed a very similar
Yeah.
trajectory.
They also got a lot of their tools, their security tools,
Yeah,
which
tools
was bad.
that are now
That's
mostly
also big bad.
ended up
For sure. Okay, so, sorry, that was fun. We'll put that away. Let's wrap this up for a little bit. So what is the last step of the response process that we haven't completed yet? He mentioned like 500 frameworks, and I promise there's 500 more of incident response frameworks. What's the last step? Remediation. We'll get to remediation, but yeah, what do we do first? Okay, we have evidence that we have compromised endpoints. We have someone on the network. What do we need to do? Contain. Eradication. I call it GTFO. Get them out, right? Let's get them out. So how do we get them out, and how do we keep them out of our network? What do we need to do? Disconnect what? Yeah, disconnect, isolate, right. Okay, so a couple things. So we know they've established persistence, right? We know they have rats on our network in a couple places. We know there's been shares created. They may have established persistence that we may not know of, that we may not have found yet. We have their IPs. Do we want to just block IPs? No, why? Yeah, they'll just roll their IP and come back with another one, yeah? Yeah. What's a level higher than an IP? Domain. Perfect. So we can block their domain. So let's look at what their domain is. I want IP. Yeah, I can just do it here, right? Where's our IP? So they are a German Hetzer online gambling domain. Do we block this domain? This is all discussion. For the rest, this is all going to be discussion, so bring it at me. Do we block this domain? What do you have to do before you confirm that that domain should be blocked? Policy. Maybe we have a legitimate reason of working with this online German gambling company, right? So talk to the powers that be, talk to your team, talk to your executives, talk to everybody, because you want to validate that we're not just blocking domains. This might be a legit customer, and if it is, you have another problem. Okay? So we have validated that we have no business or any reason or need to work with this German online gambling site, so we're going to go ahead and block the domain. But it's just a great note as we talk about kind of incident response and eradication. Let's see. Okay, I may have mentioned something, I may have buried the lead there, about another persistence mechanism that we may not have found yet. Does anyone have any idea what that could be? If you think about it, you have administrator rights to the domain controller. There you go. Perfect. Let's go look and make sure they have not done that, because that would be a perfect idea for persistence. I love that you're just take it with you. Does anybody know what the event ID is for a new user created? Google does. Oh, good call. 4720. Boom, 2 events. User event created, gone.kahlua. I'll let you assume from there. So they created a new user. We can go ahead and look at that username. And see, you go through this is actually the user. If you go in, we'll bypass that part, but you go in, you see the creation of the Z drive. This is the user that actually created the Z drive on the HN file server, and then this is how the inet info executable was spread. And then you see the user being created, added to the domain, and then added to the domain admins group for higher level access. So what should we do with this user? There you go. Bye. Bye, Felicia. Blow it up. Bye. All right. What else do we need to do to recover the environment? Yeah. Right. Absolutely. Remove those artifacts, right? Remove the inet info executables. Remove the malicious files. What else do we have? Exactly. Yep. The domain, all those steps are taken. What else? Oh, registry key. Anyone remember that thing? Probably want to get rid of that. All right. So let's say all of our systems are eradicated from malicious artifacts. We're going to say, so we're going to do a real quick debrief of the actions that we went through, just kind of walking through attack, and then we're going to discuss mitigations, and then we'll be done. And I will let Yuri dazzle you all with his hardware. All right, after action review, we're just going to kind of walk through this pretty quickly. So this scenario, the attacker managed to compromise a computer, the HN workstation within holy.net, using that spear phishing payload that we saw in the email. After successful payload execution, the attacker runs several commands to gather information, does enumeration on the network about the initial target, which was that workstation 1, and downloads a tool for lateral movement. The attacker performs a port scan. Oh, we didn't see the port scan traffic, but it's there. And laterally moves across another network to another target of the DC, the domain controller, DC01. The attacker copies and runs inetinfo, a payload on the domain controller, establishes a session while making the backdoor persistence via a registry run key. The attacker then enumerates the domain controller, traverses the network to identify and dump password hashes, and view other computers within the environment, create a new user account, which we saw, granting it domain and local admin privileges to perform lateral move to another target, which is the HN file server. They make the backdoor persistence via registry run key, enumerates the information, and then exfiltrates sensitive data from the file server, including network diagrams and the secret documents. Before finishing the attack, the attacker clears event logs on the domain controller to cover its tracks. Yeah? Sorry, repeat your question? Yeah. So a Z drive was created from the Gone Kahlua that they created that user account. So they created the Gone Kahlua, then they created it and added it to the domain admins group, and then you created a Z share. Awesome. Okay, and so they cleared event logs to cover their tracks. So real quick, these are just some of the IOCs discovered. We didn't go through all of them, but it goes through all of the tactics within MITRE ATT&CK framework and all the IOCs that have gone through just in this scenario. So we covered most of them. I would have bored you to death if we would have gone through all of them, but this just gives you an idea of some of our scenarios. Okay, so our next goal, to kind of just discuss quickly and kind of brain thought experiment, what about mitigations? What could we do? Here's some that I thought of. Mitigation, recovery. What configurations could we have made in the network to stop this attack from happening? Yep, block macro enabled files, perfect. What else? Yep. Absolutely. Yeah, user training, 100%. Anything else? DNS misconfiguration, perfect, that was identified. Sometimes you find plenty of problems that are identified when you're walking through an incident response. Motion. Anything else? Any other ideas? Are we done? What's next? Oh, yeah, executables, perfect, that's great. Yeah, I love that one. User, what did you say? Rick should not have had permissions, yeah. Did you have one? No? Yeah. Create alerts for a specific kind of log on to the domain controller. That's not Kerberos, right? Or users logging directly and using their credentials to the domain controller. Okay. Yeah. Yeah. So, in security, we're never done. I think that's the answer, right? Our team has to be done enough to feel confident that our operations have been restored back to normal. But I think something really important here, and kind of the last point I want to leave you with, is there's a question that we don't ask ourselves enough. Whether it's a leadership position, hands-on keyboard position, whatever, is what could have happened? What else could the attacker have done? A lot of times, especially hands-on keyboard people, we get stuck in the weeds of identifying all those pieces of traffic, going through traffic. We get kind of a short scope, narrow scope, and we get to this mitigation and recovery piece. We don't ask what else could they have done, what other actions could they have taken with the access that they have. So looking at this real quick, let's go. I just want to show you, as we're kind of talking about IT and OT, if they would have simply, instead of traversing the firewall here, and gone into the file server and gotten the CIA and FBI documents, where else could they have gone? Absolutely, right? Instead of picking left, they went right? And then you go to the OT firewall and you get into your OT network. What does that take down? Chemical plant? That's a problem. That could have caused catastrophic events. I mean, arguably, what's worse, CIA documents or taking down a chemical plant, I'll let you be the judge of that, right? But we don't ask ourselves in security what else could have happened. I think the other point I wanted to make is, we're never fully done. Our team as a whole, we have to prioritize, when is enough? But if you implemented all the security controls that we just suggested, all the security controls, and then you don't do anything with them, how do you know if they worked? How do you know if those security controls work? How do you know? Yeah, where'd it go? Where's my candy? Are we out? Oh man, I owe you $1. Because that was the best response there. Who said it? Tested them. There is so many times where people think that they can get a security tool, pull it out of a box, plug it in, and it works and you're secure. Or you go through a full incident response motion, take out all your artifacts, mitigate everything, put every single security control in the world, and like, okay, we're done. If you don't emulate, if you don't test those security controls, you have no idea, one, if they're done right, and two, if they're protecting what you're trying to protect yourself from. So emulate, test yourself, practice your incident response training within your team.
One thing that I think is interesting carefully is that you're showing how IT and OT are connected.
Absolutely.
And that is the trend that over time, that OT operations and other stuff live in its own world, and the IT world and OT world really mess that up. Now it's going to become more and more. Oh, sorry. The mic on here? The IT and the OT worlds are connecting more and more, and this is one thing that Bree showed you. I just want to emphasize that it started with an IT hack, but then notice it opened up an opportunity to get into the OT world. It used to be the OT world was very much by itself, and the IT world was very much by itself. They're now being combined. Similar, one device will have IT and OT installed on it. So it's very important to understand, as I mentioned earlier, that critical quad kind of idea. So I just wanted to bring that up, that Bree did that.
And perfect example is, who remembers Colonial Pipeline? That was an IT attack on their IT systems. And to be honest, I mean, this is my own opinion, I feel like they were successful at blocking and responding to that attack because their network was segregated correctly, that the attacker on their IT network, they took everything down. I think it was, 5-6 days of operations that they lost, but no attacker got into that OT network. So kind of very reminiscent of this type of network that I just shown you, and one simple misconfiguration can either be a success in getting attackers out of your network and saving your organization millions of dollars in operation costs and loss, or if you don't test that configuration, it can lead to something really, really bad. So that was it. I hope you guys had fun. I hope you guys got candy. We're out. So at least you answered my questions. And if you didn't, you got some candy.
Finish with anything, or are we? Okay, Bree, thank you so much, everybody. Give Bree a great big hand. Thank you. Now, Yuri, before we have you join in, how about, folks, we take a quick, 10-minute break? Does that sound good? Yuri, is that okay? 10-minute break. Okay, I'm not good at math, but let's just make it so we get back here at 1:45. Fair enough? We'll see you back here, and Yuri's got some really cool stuff to show us along the same lines. Thanks, guys.
3 hours or 6 hours in? 6 hours in. Okay. All you need is like the minimum. You know, like 6 credits for English, 3 credits for math, and you're good to go for 1 year. That's it. And then whatever other requirements fit, you might be like, and then go talk to your teacher and say, hey, what I need to get for whatever recommendation. My branch at Sierra. The Sierras are the upper tier. Oh, what I do. So that was like the Tony Cobb Sierra, and the other was like a. November is the devil. And they also have 110. I get both of those. The 170 like the yeah. So anything we're gonna the first two and then 255 carry 170. Right. Well, it's not that. So you have to do as once commission or become okay. That's one of the factors. They want you sub senior. And the other factor is now in theory under the old system, this is changing the army, and it hasn't stopped yet. But any kind of permanent profile, any kind of once they do their process, they talk with the Red Army. They will tell you, yes, there is a way to process. No domestic license, no foreign. They have ever received that waiver. It is thick, and it's called a threat. So, yeah. I know he's been around, done some things, and he's got problems. You know, this says I have no. Especially that I got shot at. You know. But. Minimum requirements. I know, like, depends on what the base is. Also, anything you require to ask for. Or yeah, 36 months after you get rank and your classification. So I had a 2-6. What if I already have it? That's a good. When I did it. I left there in 21. I was an instructor at Vincent Hall for Sierra. So same building, different group, but I hung out with some of the elders. It was the same. Typically get 4 times. Part of. That's why I asked. It doesn't have them. Really?
Aha, nice. Way better.
Welcome back, everybody. Welcome back, everybody online. Hello. Welcome back, everybody here. For those of you who are outside, come on, Ashoka, if you can shoo everybody in here. We are continuing the fun. We had earlier Bree talking to us from Cloud Range about, hi Bree. We were just talking about you. Bree talking about, basically you could call it hacker life cycle, anatomy of an attack, what have you. And so we saw exactly what it means to visualize an attack. Yuri is going to be discussing some similar things, but with some real differences, hitting the edge, also talking a bit about self-healing and other issues. Everybody, if we can get a big hand for Yuri. Yuri.
Yeah, so I just want to kind of get back and pick up exactly where James left off with the intersection of IT and OT, and that's exactly what we're seeing at the edge, right? Because can actually anybody name what OT actually is? Operational technology, right, but what does that look like? What does that mean to you? Okay, sensors? Yep, fair enough. Anybody else?
So the network exists to transport data and to send messages. What are the
Sure.
what is involved in the messages is the OT. What is
There we go.
the network exists to transmit data and
Go ahead and turn the mic on. Thank you.
the network exists to transmit data and to send messages, and the OT is really what's creating the messages or what is causing the need for the transmission.
Sure. I mean, that is a very good way to answer it. So, you know, back in the day, realistically, your OT was any sensor, anything that is doing the autonomy work on the floor, any cameras, anything like that, right? These days, the computers are actually getting small enough to where those sensors are becoming your compute. So they're becoming one and the same, essentially. So, and that's kind of what we're looking at is whenever those sensors become part of the compute becomes the sensor, how do we secure that? And what is the actual threat to those devices, right? So I guess, for example, a security camera. What is the biggest threat to a security camera? I'm sorry?
Oh, hold on. Folks online need to hear you.
Perhaps lack of updates for outdated Bluetooth protocols?
Yeah, it could be updates.
That one, here's another victim here.
Integrity and availability.
Integrity and availability.
The lack thereof.
The lack thereof, right. If the camera goes down, it's useless. What else? One last thing that's going to be a threat coming off of an OT device. The data that it's actually pushing, right? If somebody's trying to capture that data that it's actually pushing, that is also a cyber threat. So that's something that we're going to kind of go over really quickly. We're going to go over scenario. We're going to go over the network defense and sustainment, file and object defense, and then we're just kind of going to wrap it all up. So operational network security, encryption, dispersion, and redundancy, right? So I would say that's the biggest things that you need to do to secure your network whenever we're talking about OT or whenever we're talking about anything extreme edge. And whenever I say extreme edge, this is actually a really good question. What does the edge mean to, I don't know, anybody? What is the edge? Okay, that's the edge. Anybody else? I mean, technically, would your CP be the edge? It's not in the data center. It could be the edge, right? Your branch office can be the edge. Everybody defines it differently. So I guess what we're talking about here is more so on the extreme edge, right? And I kind of want to differentiate that just a little bit just so whenever we're talking about those OT devices, we're actually talking about small form factor. We're talking about something that's streaming, and how do we actually secure that, right? So one of the biggest things, and especially that we have seen in the military and DoD in general, is the use for autonomy, right? Whenever we're talking about operational scenarios, what is the biggest threat to a CP right now digitally? If they can find it, they can hit it, right? And if they can capture the data, they have everything they need to know. If they degrade your communication, that also becomes a threat. So those are your top three. So how do you beat that? With encryption, dispersion, and redundancy. So realistically, in the scenario, in the perfect world, what you would have are autonomous edge devices that you operationally, and this is something that, you know, as operators, we need to learn as skillcraft. It's not something that is going to be by the book. So whenever I talk about a lot of the stuff that I'm going to talk about today, this is more so learning how to think for yourself and how to come up with these scenarios and how to overcome some of these challenges and not just be very prescriptive, right? So putting out, whenever you're going out on a mission, putting out autonomous devices, something that is actually rerouting the data that is coming out of your main edge data center, if you will, and that becomes the beacon. So if that device goes down, what will happen? You just reroute it through another edge node, right? Your mission never stops at that point. And one of the biggest things, so you have your edge A there, you have your autonomous edge, your operational edge, which is going to be sitting at the CP, and then you have your campus networks. The campus networks are the ones that are also going to be monitoring your out-of-band, right? Out-of-band is super, super important, just because whenever the networks do go down, how do you know that that device is still alive? Or if you do need to reconfigure it, that's how you reach it, right? So whenever we're actually talking about taking that device offline, if it does get attacked and somebody actually gets into it, you have another path in to either shut that device down or re-push the configuration so the ephemeral data just gets reconfigured and you're just back up and running again. And the last thing is quantum. How many people have heard about quantum on the edge of security these days? And I guess, what is the biggest threat from quantum right now? Sorry? It's going to break all the encryption algorithms, right? But I guess the real question is, what is the threat right now?
What is the what right now?
The quantum threat right now. And personally, I would say, like, realistically today, there isn't one.
There isn't one.
There isn't one as of right now, right? But not yet. But what a lot of the actors are doing is exactly that. Is everybody's harvesting the data. So once that leap does come, they can get it all and they can decrypt it. And how long does DoD classify data for? 50 years, right? So in 10 years, it's not very far-fetched to say that quantum will be around and that will be decrypted and they'll be able to get everything, right? So how do you overcome those challenges? And that's something that we're going to talk about. One of the softwares that we work with is Arista. Anybody heard of Arista networking? So Arista actually runs a lot of the networking in data centers, hyperscalers. They're actually very good at backplane, data plane. And the one good thing whenever we're talking about cybersecurity, so they actually have single code base. It's a single code base across any device that you go to, whether it's virtual, physical, large, small, whatever the case may be. So whenever that is a single code base, your CVE count comes way down. And that is one of the biggest things, especially whenever we're talking about appliances. That's one of the biggest threats, right? So that's just, this is kind of like a network depicting exactly what they have going on. So they have a data plane, they have a management plane, and they have a control plane. All of those are divided into in-band and out-of-band. So your management plane is going to be completely out-of-band if you have it set up correctly. The telemetry actually goes in with the user data packets. So it doesn't actually waste any extra space on the network. All right, so now we can actually log into CloudVision. So what we have on this device right here, and let's actually log into it and take a look. All right, so this is actually one of our edge devices. Pretty robust, super reliable. Still a lot of space, but it has 2 WAN links going right now. So for this scenario, we have Arista Cloud Routing. We have our Fusion Trust, which is doing essentially quantum-resistant file storage. Scatter, which we'll talk about, and the host just to kind of see what's going on inside of everything, right? So Arista Cloud Routing is doing a complete pass-through, so they are the ones, that is the device that is going to be creating the redundant links. So whenever we actually look at the EOS, and we'll look at the dashboard and the cloud, so this is the device that we're in right now. We can see that it has a heartbeat, we're at 253 millisecond latency, so that is actually the control plane. That is the connection that's coming back saying that it's alive. So even if the links are down, as long as your out-of-band is up, it will tell you whether that device is alive, what version it's running, and it will still give you those statistics. One of the coolest things, and whenever we're talking about CVEs and bugs, and if you're a cyber professional, everything is going to be listed right there. This resolution doesn't like me, so let me change it back. But your CVs and exploitations are there, but how many of you are familiar with networking? Okay, ARP table. What does the ARP table tell you?
Access, MAC to IP address.
MAC to IP address, so exactly.
IP address to MAC. Sorry.
So it's actually what's connected to the device, right? It's what is on the network. And I guess what is one of the biggest challenges that people have seen with ARP tables? Sorry?
I would say poisoning.
Poisoning? Yes. They're also ephemeral. So whenever you're actually doing a response, right, and you're looking for something in ARP table, once it's off the network, it's gone. Yeah, and that's one of the biggest things. So what we can actually do here is there's a database running, and we can actually go back in time as far as you want to go back. And that ARP table will always be there. And it'll show you every single event that happened. So whenever we're talking about cyber remediation, just seeing what was on the network, that is actually a very good tool. And then we just go to being live. So what we have going on interesting. Let's look at the topology. All right. So we have 2 tunnels going out. So we have WAN 1, WAN 2. You can actually physically see them sitting there on the desk. 2 completely separate carriers. So each one creates 2 tunnels to the cloud reflectors, right? The cloud reflectors handle all the traffic routing between the nodes. So whenever the device actually creates a tunnel to the route reflector gives it the advertisements to every single neighbor that is out there, and it dynamically creates connections to those neighbors. So it first reaches out to the route reflector, and then it creates its own connection to every single neighbor out there. So each IPsec tunnel actually has 2 tunnels inside of it. So they're bidirectional tunnels. So whenever we're talking about capturing traffic, even if you break into the initial tunnel, you still have 2 bidirectional tunnels going inside of it. And that is actually going to be per connection per WAN network. So right now we can actually see that 210, one of my WANs, is down on IPsec. Let's find out. And if you guys, anybody, any CCNAs in here? Cisco guys? Okay, you'll be very familiar with the rest of it. All right, so those are our connections. We have the management backplane, and now we can actually look at our tunnels. Yep, so we can actually see where IPsec is still pending, it's inactive, but we can see the dynamically created tunnels that are just done by right reflectors. So if we take one of the networks off, for example, just unplug it. We see exactly how it drops. So the connection dropped to the cloud reflectors, but the dynamic tunnels that are there, and this is whenever we're talking about when the devices go offline, those dynamic tunnels that are created to its neighbors persist. So they will actually stay there until it reaches out to the cloud reflector again, or it goes back online, and then it receives those advertisements again, and we can set that timer as long as we need to. So if we actually have a mission that is going on, we can actually advance that time to 2 days. And it wouldn't have to reach out to the cloud for up to 2 days to get those advertisements, and it will keep those dynamic links active. Okay, and then that's something that is actually done through stun. Anybody familiar with stun? Yeah. So stun, hold on. Let's plug this back in. All right, so we can actually see where that connection dropped. And those tunnels have become unhealthy. So this is an amazing network monitoring tool. But as soon as that WAN connection comes up, it'll reconverge and it'll reactivate those tunnels. So it's something that it does on its own. It doesn't whenever the network goes down. So if your paths out are Starlink, cellular, whatever the case may be, it automatically, dynamically finds your neighbors. So as long as you have a way out, or even if you don't, the connections in between the devices, and we're talking about wearables, we're talking about small devices. So we have a wearable, we have anything from a network stack to just that compute module, it'll stay online, right? So, and that's whenever we're talking about availability, that is it. So, the other side of it.
Could you go back to that one real quick?
Yep, one sec. That. Mm-hmm, absolutely. Yeah. So, has anybody ever heard of scatter? Yeah? Okay, perfect. So, they're doing something cool, and it's something that we'll talk about. So whenever we're talking about the adversary is actually capturing the data that is coming off the battlefield. So scatter is one of the tools that is being used to overcome that. Because at that point, whenever you capture the traffic, you capture only a small portion of it. So what they're doing is they're actually taking the data, they're dividing it up into sessions with stun, And each session is actually a different protocol, goes to a different IP, and gets recombined at the other end. So even if you capture the data, there's really no good way to reconstruct it, how the packets go back together or anything like that. And that's actually something that we have running here. So we have 4 channels that are currently up. The device is online. Our out of band is still has a keep alive. And here we can actually see the channels, the protocols that they're running over, and the next hop IP that they're going to. So whenever you're looking at the traffic, not only is it hiding the traffic, one of the other biggest things is whenever we're talking about traffic that is coming out, every traffic has a signature, right? Whether we like to acknowledge it or not, every traffic has a signature. And whenever you actually push it out over different protocols, that signature seems to dissipate. Because whenever you can actually control which protocol is going over, it just seems like regular traffic at that point. Because in the DoD, what's the biggest signature for all the traffic that you have coming out? Type 1. TACLAN, right?
What is that?
Type 1 encryption. Has a very specific signature. Or whenever we're talking about certain VPNs, they have a very specific signature. If you can divide that traffic into just what looks like to be either SIP traffic, mail traffic, whatever the case may be, it just looks like regular traffic on the network. You don't have to create that signature. So that is another way to defend the network. A, you don't become a beacon, and B, you resist the capture of the data through multipathing. And the last one that we kind of want to go over is file storage. So we actually have a tool called Fusion Trust, so it's created by Hypersphere. So what they're doing is essentially kind of the same thing as Scatter, but they're doing it at the file level. So what you will see is a lot of the encryption that is happening right now is happening on the drives, but it doesn't happen pre-drive. So whenever Hypersphere actually stores their objects, they have gotten quantum entropy. Does anybody know what quantum entropy is? Essentially a derivative from a quantum equation that just causes randomization in the algorithm. So whenever you apply quantum entropy to, say, like AES 256 or anything like that, right, to any algorithm, it also creates randomization in there. And what these guys are actually doing is it divides up the file, every single file that you store, and it creates a different key. And they're rotating keys for every single file. So it's pretty interesting. And I would say the best part of that is there is no central KMS. So there is no key management, which is one of the biggest issues that is happening in the cyber defense world is somebody can break into your identity, right? If somebody can break into your identity, into your DC, they can get to your KMS, they can get to the keys, which identity will always be an issue, but this kind of overcomes the key management issue. So let's see if it'll actually, doesn't like me right now because I resized. Let's see what happens. Aha. So what it does is it actually creates separate vaults with a S3 algorithm. So it's essentially created on AWS technology. You can create S3 buckets, whether it's on local devices or whether it's in the cloud. You can actually choose when that data gets pushed, whether it gets pushed to the local device or it gets actually multiplied across different buckets. So it can actually push out different times. One of the reasons for that is if somebody captures or encrypts your device, then you still have a backup copy somewhere else, right? So in these vaults, what we can see is, for example, in orders, right? We have 5 different objects, and you can't tell what they are, right? That is all you can see out of the files. And we don't know how many files that is. We don't know how big they are. We don't know anything. So whenever an adversary breaks into that file vault, they have no idea how to reconstruct that. And the only way to do it is with the rotating keys. So if we actually launch our logged in file explorer, we can actually see that those 5 objects is that one PNG, is that one single file. So that's essentially how they're kind of overcoming almost exactly the same thing with scatter, but at the file level and pre-disk storage. So everything gets encrypted at the engine. It is software-based, and then it gets written to the S3 buckets, whether it's in the cloud, whether it's local, whether you want to send it multiple different ways. Yeah, so those are just the few technologies that we've seen that are helping kind of overcome the problem at the edge of capturing traffic, overcoming the redundancy issue, and realistically, even going back to everything that Bree went over, the biggest thing to overcome is just being good at the basics.
Is what?
Being good at the basics. If you're good at the basics, you'll figure everything else out. And I feel like as cyber professionals, a lot of times we always want to try and figure out, well, what happened? What was the biggest thing? And it's always it's always something simple. It's always that email. It's always somebody clicking that wrong link. I mean, yes, it does evolve into something way bigger, but if you're just good at the basics and you never click that link, it's one less thing for you to worry about. So yeah, it's kind of just something that we went over was network security, counteracting the harvest now, decrypt later attacks, the quantum resistant automatic file encryption, and I would say one of the biggest things is on the edge investing in containers and containerization, and I'm sure that has been a big topic for edge devices, but why is containerization a big thing on the edge? Anybody?
Say it again?
To limit exposure.
To limit exposure, exactly. It creates another layer that actually takes all the containers and disconnects them from the OS, right? So there's another way in, there's more authentication, there's more segregation. Yep, absolutely. So just kind of like last thing to think about, but that's all I have, guys. Questions?
Yeah, thank you. Questions, folks? Folks, does anybody have any questions? One of the questions I have, we talked earlier about the idea of self-healing networks and things, and specifically, I guess I had a very simple mindset about it, because when it comes time to use something at the edge to overcome an attack, I'm worried that as a person who offers a service, something in real time,
Right.
and a system gets compromised, you take it offline or you replace it very quickly, but you lose state, at least traditionally, because if you replace an image or replace a working operating system that's working in some sort of workflow that's fulfilling a client, and then you take it out and then replace it, it's been hacked, you take it out and replace it, then that state is lost and the customers are unhappy. But that doesn't happen with what you're talking about. Is that fair enough? Maybe you can discuss that further.
Sure, yeah, and That is a fair statement, and whenever we're talking about this, and this is something that we mentioned in the beginning with the autonomous nodes and actual operational nodes, your autonomous nodes are the ones that are going to be running your containers. Containers, in essence, are ephemeral. What does that mean to everybody?
They go away.
They go away. If they go away and they come back, it's going to be the exact same thing, right? They don't actually store any data. So where does the data come from? The data comes from the operational nodes, and those are the nodes that we need to harden. Those are the nodes that are sitting at your command posts. But your nodes that are sitting at the edge, they should be automated enough to where if one node goes down, it just comes right back. Next node comes right back up, or you just reload the config and it's the exact same thing. They are stateless. The data doesn't live out there. If the device goes offline, it still has the persistent data on it, right? But whenever it reconnects, it'll just sync back with the cloud, it syncs back with the central office, it syncs back with whatever the case may be. So everything on the edge should be the ephemeral nature. And it's kind of going into the way we think about technology as a whole in general. Just because from what we've seen over the past 20 years is everybody's going out and we have these giant network stacks and everybody needs a router, a switch, a server, and everything else. Now you're looking at managing Cisco, Juniper, you're looking at managing all these different multiple code bases. You're looking at managing different devices. Your attack surface exponentially increases. Which now, if we actually look at the future and we look at how do we look at networks, devices, OT, and IT on the edge, that is your router, that is your switch, that is your sensor hub, that is everything sitting in that one box. If that box goes down, you have another one. You just replace it. If something happens and it gets attacked, you push the containers to it again, it gets reloaded, maybe it gets reconnected to the database, right? The config for the router, it gets reloaded. The automation should already be there. And future-wise, that's how we should be looking at the edge. It should be cheap, replaceable, something that moves quickly. It shouldn't be these giant stacks.
Interesting, so it's kind of a microservices approach to security there. It keeps costs down as well, right?
Yeah.
So interesting. Do you work at Cubic work very closely with AWS on some of these things? Is that accurate or is that not accurate?
That is accurate. We have also done, so AWS also has essentially the same framework as Arista does. They're running Junipers and they have the same kind of self-healing failover network, and they have one of the biggest networks out there as far as it comes to fiber, and especially once Kuiper comes online, that's going to be an additional benefit.
Chung, what are some of the things that, in terms of what Cubic is doing, in terms of self-healing networks, or in terms of work at the edge? Because I think a lot of people here would like to know more about the edge. Is that something you'd be willing to talk about, or?
I mean, a lot of what we do.
Oh, sorry, you get to come up here and talk, sorry.
I mean, a lot of what we do, Yuri already talked about, right? So one of the things we have been doing at the edge, instead of scatter, we use dispersive, right? So it's kind of the same thing, multipathing. It's a phenomenon. It's not new, right? It's moving target defense. So instead of not only are you splitting the traffic, you're also changing the path that it takes to it at a regular interval, right? So even if someone thinks they found all 5 of your splits or 5 of your paths, it's going to change again, right? And it's based on a rotating key of which direction you're going to take. And obviously, the other thing is multi-nodes. I mean, obviously, when you're forward deployed, you want to have your data probably replicated across 2 of the forward nodes, right? So unit A and unit B, you want to replicate your data there, so in case one goes down, the ephemeral data that you stored and that needed to be backed up to wherever the operation unit is, it's not just lost, right? Your mission data is just not gone. So those are something that we've seen.
Yeah, and so if you could just, you probably can speak to it way more than I, but we actually just recently certified our devices on IoT Greengrass. And whenever we're talking about those networks and we're talking about deploying configurations and redeploying configurations, can you talk about Greengrass a little bit? Just kind of explain what that is.
Yeah, Greengrass is our IoT, management system. So basically, it's able to track all of their devices out there and put them under configuration, right? The way we do it is we make a digital twin of it, and that when we change the digital twin, and because these devices don't always connect, so or maybe they're in DDIL status or whatnot, when they finally connect, they'll look at the digital twin that, all right, I'm going to go and replicate it as much as I can to it, right? And then you have different buckets of devices and whatnot. But yeah, in general, that's how we use it. Any specifics or?
No, that's exactly it. Yeah, I mean it's essentially management for your fleet of devices, right? And something that we worked fairly hard to get certified on, just so we can be a part of that ecosystem. Just so whenever the devices go out, it's something that you can just connect directly to, you can push configurations to, and whenever you need to reload them, there's already a template there. You just push that configuration, reload it, out of band, and just keep on going with mission.
There's a question online that we may have already addressed, but I'm not sure it has. This is from Carlisle, and is there an INE involved in this scenario? I don't know what Carlisle means by it. It's what it says here, INE. Don't know what that is. But also talking about what is the thinking regarding the CA at the end user level when it comes to. I don't know if any of those questions make any sense.
The CA, so like certificate authority?
Yeah, thanks.
At the user level?
Yeah. It's not an
guess.
issue, right, because we're dealing with it at the edge, is that it?
Right. I mean, so I guess the certificates still get propagated out there. So I mean, a lot of them are, I guess it depends. There are a lot of different strategies on how you apply the CA. The CA definitely doesn't live out there. Certificates are pushed out to the edge. You create your secure connections, and especially with as long as you have the out-of-band management to push the configuration can push the SSH keys. Once you have the SSH keys and you have a secure tunnel established, then you can pull the certificates. So I mean, it just depends on how each organization sets up their services. But I guess that's one approach.
Now, I'm going to ask, you're already up here, Yuri, but Chung and also Bree, if you could stand up here. You might want to turn up my microphone. I don't think it's on. Just stand up here because I want to ask some questions as we close this out here.
So let me jump into that regarding this, the certificate for the end devices and online. Let us know if we're completely off base on this one. But the certificates is a way for us to kind of ascertain that these devices are ours. But that doesn't mean you completely trust them, right? I'm not going to say 100%. Yeah, that whatever code that thing's pushing back to me, I'm going to trust, right? It's just another layer that we say that we can tell that that's part of our network.
Yeah. Thank you. One of the things I want to ask the three of you, from a kind of a network cybersecurity expert perspective, these folks are here doing continuing education credits and things like that. When it comes to the edge, Chung, or when it comes to monitoring hacker activity, Yuri and Bree, what are some of the skills? And I'm noticing here orchestration. Understanding therefore things like suddenly it escapes me. I don't know why. The Kubernetes and things like that. But what are some skills that you three feel are things that these folks should be getting that would compel their hiring manager to promote them or somebody to hire them? Do you know what I'm trying to get at? What are some of the skills right now that you feel are really important? Start with you, Chung, and your way to Yuri and to Bree.
I mean, basics is, learn how to work your way around a Kali box, right? Learn all the system tools and whatnot that you can use with it. One of the big things I've seen, you use machine learning, right? Not AI, I'm not going to throw that buzzword around, but use machine learning, use algorithms to detect anomaly, right? So use, obviously Splunk or CloudWatch or any of the other tools have their own anomaly detection. But what if you want to do anomaly detection like just on, Windows Server events, right? So learn how to get your Kali box out, download the entire set, and then run something like isolation forest, right? So it does like the nearest K neighbor evaluations on all the data that's in there, and it tells you from a 95% confidence that this traffic pattern here is completely different than anything I've seen coming from this server in the last 90 days, right? So you may want to take a look at that. I'm not sure if it's been compromised or something's weird with it, but there was this blip that you really want to go take a look at, right? So anomaly detection is a big kind of thing because it helps you direct your attention.
Yeah.
Thank you. Yuri, killer skill.
I mean, I would just say that the biggest thing would be cross-discipline learning. Understanding how networking works, understanding how systems work, understanding how satellites work, tying all of that together, IT, OT, even if you don't have a very high-level understanding of everything, if you understand a little bit of each, you're able to tie it together. Whenever you're able to tie it together, you can put together the big picture, and that's kind of what I'm talking about, being good at the basics. If you're good at the basics, and Jung mentioned it, across the board, you can understand the bigger picture, and then you can start moving forward from there. And that's when you become truly advanced. Because whenever you're truly advanced, and this is just a personal opinion, but whenever you're truly advanced in networking, but you don't understand systems whatsoever, it doesn't really serve you whenever you start looking for different attacks and different vectors. I mean, it's great, but if you can understand systems, you can understand networking, you can understand cyber, even at the basic level, and you can start like as the building blocks, and you can start building from there, I think it'll just be so much easier. It'll be so much easier just to see the entire terrain.
Bring that up. It's interesting you bring that up. Renee Wynn, who used to work for NASA as a CIO, she brought up the biggest problem we have is the failure of imagination. She did talk about the importance of understanding the big picture, especially with AI now that we have. AI has the ability to take heretofore very small little issues and build them up into large issues. And it's not just AI doing it, it's automation. So
Yeah.
for that. Bree, what are your thoughts? Killer skills.
Do I have mic on? Oh, awesome. I have a whole bunch of conflicting thoughts all at once. So quickly, just to agree with you completely, from an attacker red team mindset, I think the two biggest threats out there and the two biggest types of attacks that we're seeing in the industry that are shifting, not only increasing in scale, but we don't have enough defenders to know how to defend them, is OT attacks. Because I grew up in Windows systems. I grew up as sysadmin, net admin. We grew up in all traditional IT networks. Now that we're seeing the threat actor activity shift to OT networks, you think the people that have ran the OT factories know what a packet, know how to find packets, right, in traffic? No. And so there's a lot of people in cyber that are having to relearn the basics of how those systems work, how those networks work. That's different ports, it's different protocols, it's different traffic. It all looks different. So starting at the basics, learn Modbus, learn DNP3, learn all of the different protocols and how that looks and how that, and compare it to what traditional traffic looks like. The other types of attack that I was going to mention is supply chain. Kind of hand in hand there, but those are the two scariest attacks that keep me up at night. And the two probably going to make the biggest impact. For someone learning in security there, I will only slightly disagree with you because kind of being involved in all different training environments with so many different methodologies and ways and topics and subjects and things to learn on security, it can be so daunting and overwhelming. The thing that sparks your interest the most, learn that one thing. Start at the foundation, start at the basics, because when you start to feel yourself learn and understand and grasp the concept of something that really starts to spark your interest, whether that's threat hunting, whether that's incident responding, whether it is Kali Linux and you want to do ethical hacking, pick something in that realm, learn it all the way up to the top, and then that will start to cross-functionally learn about other roles, other topics in security. I just think if you look at it as a whole, there's too much. There's never going to be a cyber expert that's a cyber expert on all things cyber.
You can't boil the ocean, huh?
Pick one thing and go for it.
Now, I've grabbed the microphone here. Anybody want to grab the microphone and ask a specific question of our august panel here?
Yeah, last thing I want to add to that is that
go ahead.
do learn some coding, right? Like real data structures and algorithms. Yeah. No, yeah, so like, a lot of times, like, all right, I need to get, the most commonly, hit IP over a certain amount of time during these mean days or in the month of August, right? Throw it into database, do a SQL query, like basic data structures, right? Or how to loop, I'm not talking about writing an entire program, right? But basic data structure and algorithms so that you can manipulate text structures is really important.
Question for both of you, if you don't mind. What kind of keeps you up at night? What are the biggest threats that you see to the security realm that's gonna rock our world, so to speak?
Threats?
For me, it is and has always been physical real-world threats to people with administrative rights, right? So whether it be phishing, whether it be another form of, a coercion, because I can't protect against that. So it's training, right? And unfortunately, not everybody takes training the same way. Not every command takes training with the same urgency, right? I mean, that's the one thing I can't protect against. At some point, I have to trust somebody.
It's that
Yeah.
element that we can't control.
I mean, I guess for us, one of the biggest things, and just because we work in DoD space, and it's a little bit different, but how do you do LPI comms, LPI, LPD, everybody familiar with low probability of intercept, low probability of detect. So how do you do those types of communications, and how do you protect your communications? And how do you quickly rebuild these systems to where they're never down? Or even if they are, we're still able to keep shifting that how do we become the masters of our own cyber battlefield and cyber domain to where we can shift the networks by ourselves? And so, yeah, the denial of service, because at that point in the DoD world, that costs lives.
Yep.
It's not just money, which is very different. And yeah.
Fantastic. Thank you, sir. I'm taking notes. Taking notes here. Any additional questions from the crowd here? Stephen, how about online? I don't have my online with me. Anything going on? Anything else?
Touche. EMP. And that is something that some of the devices have to be certified to withstand. To a point.
Sounds like somebody's worried about us going kinetic. Right. So, right. Everybody, let's give Yuri, Bree, and Chung a great big hand. Thank you very much. Now, I'm going to basically conclude this session. I think we're about a half hour early. For those of you who are doing CEs, you can click out or tap out there on that screen. Thanks, Chung. Now, the other thing is we have a raffle to do, don't we? Stephen, do you have those raffle tickets available? And you have to be here, so let me, have you randomly randomized them, sir? Randomly randomized. So we can do this. What's that? A double negative. Yeah, I think I can do it. Zero error there. So let's see if our person is here. Let's see. Troy Bolts. Troy, are you here? Hey, everybody, give Troy a great big hand. All right. Troy, fantastic. You have a choice of a voucher of your choice. We'll work it out. Do you have an idea right now, or are you going to think about it for a bit? CAS people. Now, okay, we have a new winner. You just lost. It's now called Security X. Sorry. So good for you. That's a great way to go. Here, selfie time. All right, nice work. Congratulations, man. We got it. We'll get you Security X there. Oh, here, we'll get a. We should do it with everybody here. Everybody, come on up here, Chung. We get the important people here. So, here we go. Come on here. Get you set up with it. Thank you. Everybody, this concludes the session online. Thank you very much. We will see you next time, possibly FCA West, certainly at FCA Baltimore. So everybody take care. All the best. Bye-bye. Thanks again.